Okay, in this video, we're going to learn how to use implicit differentiation to take the derivative of some equation. So I want to look at this first because you're used to seeing something that might look like this. Let's see. Y equals 3x to the fifth minus 2x cubed, okay? And when you take the derivative of this, you're used to saying the derivative of y is dy dx, or you could use y prime, and then we take the derivative of every x. And this is going to be 15x to the fourth minus 6x squared. Well, what you really did here was you said, what's the derivative of y? Well, the derivative of y, since there's a 1 there, would actually be 1 dy dx. So what this says is the derivative of y is 1 because we move the power in front and we subtract 1 from the power, so the y goes away. But we're taking the derivative of y with respect to x, because we have an equation where y is defined in terms of x, okay? And so the rest of this would look like this, the same as what we did before. And then of course I can drop the 1, I don't need it. So I have dy dx by itself. So what you did here was when you took the derivative of y term, you wrote dy dx next to it, the derivative of y with respect to x. And then when you took the derivative of something with just an x in it, you took the derivative as normal, because this would be the derivative of x with respect to x, and that would simplify. So that's exactly what we're doing with implicit differentiation. So we're going to look at a couple examples. And this is used when y is not already by itself, or y might be a little hard to get by itself. You can use implicit differentiation. So again, here, we're going to take the derivative of terms with x in it like normal. So 3x squared is actually 6x. The derivative of y squared is 2y. However, we're taking the derivative of y with respect to x. And then the derivative of 9 is 0. And so this is all fine, but we want to get this dy dx by itself to look like a normal derivative. So I'm going to move my 6x over here, and I have 2y dy dx equals negative 6x. And then I want dy dx by itself, so I'm going to divide everything by 2y. And what I'm left with is dy dx is equal to, this simplifies a little bit, negative 6 divided by 2 is negative 3, and I have an x on the top and a y on the bottom. So this is my derivative. This is the derivative of what you see up here, okay? And now it looks normal because we have dy dx on this side. And I could use this the same way I use a derivative. If I was given a point, an x and a y coordinate, I could plug it in here to find out what the derivative was at that point, or what the slope of the tangent is. Okay? All right, let's look at another example. There's a little bit more going on here, and I want to show you a couple notation options. So this is one of them. I can write dy dx next to everything, but we know that sometimes instead of dy dx, we use y prime. You can use that here as well, but you just have to be very careful to make sure you can read your notation well and you don't get things confused, and I'll show you what I mean. So here we're going to take the derivative of y to the fourth, which is going to be 4y cubed. But remember, every time I take a derivative of y, I'm going to put dy dx next to it, or y prime. That's your other option. But this can get confusing because we have a lot of y's going on. And so I'm going to show you this, but I will generally use dy dx. Sometimes there's a lot more room for error here if this isn't noticeable, or you forget which y is y cubed and which one is y prime, because you might want to combine these if you didn't have that prime there. Okay, the derivative of negative 2x is negative 2. The derivative of 5x cubed is 15x squared, and then the derivative of 2y is just 2, but because we took the derivative of a y, we have to put dy dx or y prime. And so in this instance now I have two y primes, and my goal is to get those together on one side so that I can ultimately get y prime by itself. So I'm going to choose to move this 2y prime to the other side. And that's going to give me 4y cubed y prime minus the 2y prime that I moved, minus 2 equals 15x squared. And then I want to move this negative 2 over to the other side because I want all the y primes ultimately by themselves. So I get 4y cubed y prime minus 2y prime equals 15x squared plus 2. And so at this point, I have a y prime here and a y prime here, and all of my terms on this side have y prime. So I can take y prime out as my greatest common factor. That would leave me with 4 cubed minus 2 on this side equals 15x squared plus 2. And since I want y prime by itself, I don't want to get rid of all of this here, I can divide by everything you see inside the parentheses, which is 4y cubed minus 2. So what I'm left with is y prime is equal to 15x squared plus 2 over 4y cubed minus 2. So that is the derivative of what we started with. Okay, now I will use dy dx notation most of the time, and you can use the y prime here. You just have to be very careful not to get things mixed up. Okay, we have 2 more examples, and this one's really important because here I have an x and a y next to each other, x times y, which signals I am going to have to use product rule. So you do have to know all of your other derivatives. Trig can show up in this, logarithms could show up, anything can show up, natural logs. So you just need to really make sure you know all your other derivative rules. So check out those videos if need be, but look for product rule, that one's common. Okay, so here I'm going to take the derivative of y cubed, which is going to be 3y squared. And I took the derivative of y term, so I'm going to put dy dx next to it. Now on this one, I'm going to be very careful, and you don't need it if this is plus, but I'm going to show you anyway, because if this was minus, I would really need to be careful and probably use parentheses so that I made sure a minus got distributed. But I'm just going to use these parentheses to show that this part in here is the derivative of xy. So product rule is first times the derivative of the second, so the derivative of the y would be 1 dy dx plus the second, which is y. I didn't take the derivative there, so I don't need the dy dx, times the derivative of the first, and the derivative of x is 1. So I could write 1 in front or not. And then I have the derivative of 2x cubed is 6x squared. The derivative of negative 3x is negative 3, and the derivative of 1 is 0. And since we have some things on this side, I don't need the 0. If there was nothing on this side, I should write 0 there. But in this case, I'm good. And so if this was a minus sign, I would have to distribute through. But since that is a plus sign, these parentheses, I don't have to have them. So we can go straight to it looking like this. So I just wanted to show you that because a lot of people goof on the signs when they have a minus sign there, and then they lose some points because all of their signs are mixed up. Okay, so now I have a dy dx and a dy dx, and I want those two to stay on the same side, and they already are, but I want to be able to get them together and by themselves, so I need to move this y here. So I'm going to subtract y. That's going to leave me with 3y squared dy dx plus x dy dx equals 6x squared, and you can put this in any order, minus y minus 3. Okay, now that every term on this side has dy dx in it, I can take a dy dx out as a greatest common factor, which leaves me with 3y squared plus x on the inside of my parentheses. So this is going to be 6x squared minus y minus 3, and since my goal is dy dx being by itself, I'm just going to divide everything by 3y squared plus x. And that leaves me dy dx equals 6x squared minus y minus 3 over 3y squared plus x. And that's my derivative. Okay, I have one more example. And this one has, again, you should recognize the x, y squared is all next to each other. It's multiplication, so this is product rule. And I have a negative sign here, so you need to be careful with that. So I'm going to take the derivative of 5x to the fourth, which is going to be 20x cubed. And then I'm going to leave my negative here and put parentheses. And then I'm going to call this 9x my first term and this y squared my second term. So first times the derivative of the second, the derivative of the y squared would be 2y dy dx. Every time you take a derivative of y, you're going to put dy dx. Plus the second times the derivative of the first. The derivative of 9x is just 9. Equals, the derivative of 50 is 0. So be careful with that. And if that was all that was here, I would write 0. But the derivative of negative 2y cubed is going to be negative 6y squared dy dx. Okay, I'm going to clean this up a little bit. I'm going to multiply these things, write them a little bit nicer, and I'm going to distribute my negative. So when that happens, I get 2x cubed. This 9x times 2y is going to give me 18xy, and when I distribute my negative, that's going to become negative. I do have this dy dx next to it. Here, y squared times 9 is going to be 9y squared, and I'm distributing the negative to this and to this, so I would have a minus sign or a negative sign there as well. Equals negative 6y squared dy dx. Okay, so I have a dy dx here and a dy dx here, and I need those two to be together on the same side. And since my other terms are on the left here, I'm just going to move this 18xy dy dx to the other side. And I am left with 20x cubed minus 9y squared equals negative 6y squared dy dx plus 18xy dy dx. Now, since all my dy dx's are on the same side and there's nothing else on that side, I can leave this side the way it is. But on the right here, I'm going to take a dy dx out as my greatest common factor. And I'm going to leave everything else. Yes, I could have taken a 3 out of the 6 and the 18 and a y out here, but that would cause me more work to be able to get dy dx by itself. So in this case, we're just taking the dy dx out. We're not taking other greatest common factors out. Because here, I can divide by everything that's in here. And that leaves dy dx by itself. If I had taken other things out, I would have had more steps. So dy dx is equal to 20x cubed minus 9y squared over negative 6y squared plus 18xy. Now at this point, if you wanted to, if there was something in common, like on the bottom here, we have a 3y that could be taken out. If I could also take out a 3y on the top, I could do that and I could simplify. But in this case, taking out a 3y on the bottom is not going to allow me to simplify anything on the top, so I'm just going to leave it like this. And that's my derivative. So I hope that helped. And check out any of the videos on derivative rules that you need to. I will see you in the next video.